Hello, welcome to the 2020 Esri Developer Summit Spotlight Session, Design a Geodatabase. I'm Robert Kircher, and I work in professional services as a senior solutions architect and consultant on some of our largest enterprise geodatabase and enterprise GIS implementations. I've been at Esri for over 20 years and have experienced quite a lot of geodatabase technologies and challenges and so forth. Here's our agenda today. We're going to talk through various aspects of implementing and designing a geodatabase and using Esri's geodatabase technology. I'll give you an overview to start with, and then we'll get into some key factors to consider as you work through an geodatabase design and implementation. There's some design aspects that we'll also get into, and then we'll offer up some recommendations as we finish it up. We do have a limited amount of time to discuss the geodatabase technology, so we're going to do our best in about 20 minutes to work through this very rich, broad, and deep technology that Esri's had for over 20 years now. Let's start with an overview. So what is a geodatabase in the ArcGIS platform or in Esri vernacular? It's essentially a collection of geographic data sets that can be stored in a file or a folder format, or the technology itself, the geodatabase, can run within a DBMS. Sometimes people refer to this as ArcSDE because of the legacy of SDE, and it was the predecessor technology to the geodatabase. All those terminology, DBMS, SDE, often tie into the enterprise version of the geodatabase, and they run in the enterprise geodatabase runs in all the major DBMS technologies in the market today. The geodatabase provides a native data structure for ArcGIS, and its native data structure in many ways also is, in the case of the enterprise geodatabase, native to the DBMS itself. So there's tight integration with the geodatabase technology in the ArcGIS platform natively, and then also within the DBMS in the case of an enterprise geodatabase. It is within the ArcGIS platform, it is the primary format for editing and managing data. It's the go-to technology. And as I mentioned earlier, this technology has proven itself for over 20 years now and really started in ArcGIS 10.8, believe it or not, and in roughly 1998. And has grown since then into offering up editing and data management capabilities that span a wide variety of things, but also go very deep in all the nuances and powerful nuances of editing data. It also provides a comprehensive approach to modeling and managing spatial data. So as you guys know or are learning, when you get into spatial data in and of itself, there's a lot to think about in modeling just the location and spatial aspects of data itself beyond the attributes and common tabular qualities of data itself. On the right-hand side of the graphic here, you'll see kind of the different categories of spatial data that can be managed within a geodatabase, whether it's grouping feature classes into feature data sets thematically or whatever your application or data management needs call for. It'll store tabular data in tables, and sometimes we refer to these as object classes within our terminology. And then if features relate to one another across tables and feature classes, you'll get into things like relationship classes. These are your kind of integrity relationships, if you're familiar with DBMS technologies, kind of akin to a primary and foreign key, but much more than that. So relationship classes are a very powerful concept. And then we get into advanced spatial data management technologies and capabilities in topology and geometric networks, and survey data sets and raster data sets. These are all particular types of spatial data that we can apply the geodatabase to not only add some other capabilities in the case of a network, tracing and that sort of thing, but topology, we can really manage the quality of data given a set of rules about the topology of the feature in the spatial data itself. We can within a geodatabase, there's some rich metadata document and rich metadata management aspects on the data itself, and then a slew of geoprocessing tools that should be lumped into the geodatabase that are specific to managing data within the geodatabase. So there's a lot of different types of geodatabases and kind of a spectrum. On the left-hand side here, you'll see that Geodatabase can be used by a single user off on its own in a dedicated geodatabase that's isolated from anybody else, and editing data and accessing data and working on that data. And that can come within what we call typically a file geodatabase. And then before that, it was the personal geodatabase that ran inside the Access database from Microsoft. And then on the right-hand side, you kind of, as you move from single to many users, we have multi-user geodatabase technology. And there you can get into the enterprise geodatabase, which is your full-fledged geodatabase running in a DBMS with all the richest capabilities that the geodatabase can offer. And then if your enterprise doesn't require, or your organization or your multi-users don't require some of the advanced technologies, we can work within a group or a work group geodatabase, which is still in a DBMS, but it's a much more contained and easier to administer type of enterprise geodatabase, smaller enterprise geodatabase, if you want to think of it that way. And then from there, you can even put the enterprise geodatabase on your desktop, for example, and work from desktop to it. And that would be a desktop geodatabase. And in that case, it would be working within a DBMS, just a very small desktop-based DBMS. And then, as I mentioned, there's within the body of the graphic here, you'll see different types of GIS data that resides in the geodatabase. So whether it's the spatial data and the attributes themselves inside the geodatabase, that is there obviously. But then there's also other data that is related to GIS and mapping and so forth that resides within the geodatabase, whether it's cartographic representations and annotation and dimensions. These are all things that are stored in the geodatabase that help visualize on maps. So that's data-driven visualization on maps, like labels and that sort of thing. We've got relationship classes for data that relates to one another, either to preserve the data integrity and help ensure that, or to help in other functionality like identifies and finding related data with single clicks in our app or different app suites. And then from there, we have raster and mosaic data sets associated with imagery and others, and raster catalogs and topology for making sure our spatial data is of high quality, geometric networks, terrain, and so forth. I'll let you investigate these in our documentation. And then some of the more notable functionality within the geodatabase technology is something called versioning. This is a very powerful editing capability where essentially multi-users can edit on the geodatabase in kind of a version of the database or the data itself for as long as they want. So they can create a version for themselves and operate and edit on the data, leave, shut it down, come back the next day, and it's still there. And meanwhile, nobody else has seen that version of the edits of that editor. So they can kind of work in a project style way. And when the project's ready, they can share with the rest of the users on that data itself. So versioning is very powerful technology that we often see in users, or sorry, organizations that demand offline or long transactions, and for users to work in isolation on the same data set, and share that and post it when they want to and need to. The other technology that sits and operates from the geodatabase is replication. So the distributed replication that you hear about within Esri's ArcGIS stack really is powered by the geodatabase, oftentimes, and it can be powered in other ways, but the geodatabase is one of the key factors or components in our replication technology. A third one that's notable is archiving. So you can keep a history of all edits within the geodatabase just with the off-the-shelf capabilities, which is very, very powerful as data becomes more of an organizational asset. These are some of the notable functionality, but there's a lot more within the geodatabase stack. So let's talk about key factors. What we're going to do in this section is just kind of work through rather quickly through some of the considerations to make sure we try to help you mitigate any risks as you design your database and implement it, so you don't have to come back and rework things, because there are some things that are just if you get them wrong, they're expensive to come back and rework. Aspects of the data model as you work and develop your data model within the geodatabase, resolution and precision are crucial, getting those right. So your source data or your planned data within the geodatabase has a precision. You want to make sure that you get that right and configure it up in the geodatabase as you go forward. The other one is multiple projections. These are things you want to get your coordinate reference systems and so forth of your spatial data correct. If you don't get them right, you have to go through an expensive rework process where you pull the data out, change your projection, and reload it, which can be problematic and time-consuming for a lot of folks. Another notable one is making sure your primary keys for your relationship classes are intact. Yes, you can use the object ID, but it's not recommended, and it can be problematic in the case of certain editing scenarios, and so that relationships get orphaned or get severed, or become just incorrect if you don't get your primary key right. So again, another sort of major design consideration. The other one is you're bringing data in to the geodatabase. You're going to be converting it, and so you want to make sure that your data is of high quality, because you may have to reload it as you discover that in those loading and conversions things are lost or incorrect or whatever they might be, including vertices. And making sure that your shapes themselves are intact after the conversion. And then there are some more exotic scenarios about the size of features themselves being large and making sure that they get in there intact and are high performing and optimized so that we can get to them. Loading static raster data can be not as good a practice as it once was. In fact, only in rare cases do we want to recommend this and do this, just because it's a lot of data that there's other technologies much more suited for raster data itself. So just a few considerations there. The other one is that there's always risk in getting and making sure your geodatabase performs well, and the system performance is good and scalable. So as you add more data, add more users, add more activity on the geodatabase, that it doesn't degrade. So a lot of these things can tie to workflows, especially with workflows that are calling for versioning. You get scenarios where many versions, many states of those versions, and any archiving associated with versions start to accumulate, and those can be problematic for performance. So these can be managed, but something to think about as you're designing your versioning and other aspects of versions to your workflows, getting those right, and we can help you with that. Um, Maintaining the geodatabase is important as well to maintain the performance of it as well. So things like in the case of file geodatabases, there are tools for compacting and compressing the size of the file itself so that it is fast off disk in Arc, and this can be done in Arc Catalog. And then within the DBMS, there's database DBMS or the enterprise geodatabase running within a DBMS. There are tools in the DBMS that can be useful. Just making sure that the data files don't explode or get inefficient and that sort of thing. And then of course making sure that you use our tools for versioning to kind of trim and cull the delta tables that are associated with versioning. So again, those are enterprise geodatabase considerations. And then another area to think about is not, and I think that kind of to summarize this is there's this notion that we probably don't want to put all of our data into one enterprise geodatabase in the case of using, and not just enterprise, sorry, into one geodatabase. So all data goes into a single geodatabase. That can be problematic. So depending on your workflows and the number of users and the themes in your data, generally speaking, you're going to have more than one geodatabase running, whether it's a file geodatabase serving up pretty static data that changes rarely, to a feature, to a service. You can do that, in a file geodatabase. If you're doing replication or multi-user editing, you're going to demand an enterprise geodatabase. And then in the case of replication, you're going to have enterprise geodatabases replicating to either other enterprise geodatabases or file geodatabases and so forth. So the takeaway here is to understand your requirements, separate. Don't be afraid to separate data into different geodatabases, and choose the right format that's suitable for the use of that. Each one of those file and enterprise geodatabases have different benefits and different limitations that need to be considered. And again, we can help with that, and some of these are documented. So let's talk about geodatabase design and the aspects of that. So as you consider designing your geodatabase, there is believe it or not, a process you can go through, a design process that generally has 3 steps to it. It starts with a conceptual design, and then moves to a logical design, and then finally you're creating the physical design of those things you've designed out logically and conceptually. So in the conceptual design, you're really getting your business level goals and guiding principles pulled together. Requirements, you're identifying themes of data and layers that'll be stored in there. You're figuring out which applications are going to use this, because sometimes that'll dictate your geodatabase design. And then you're going to also leverage data model templates that we've pulled together and provided. Hopefully that'll be a recommendation I'll get into in a moment. And then you're going to document all these concepts that you've discovered. And then the logical design will happen next, where we're going to take those high-level ideas and we're going to start to put structure and make decisions about structure, whether it's the table and feature class structure or the structural relationships between those tables and feature classes and features inside your geodatabase. And then you're going to start calling out your spatial properties for your spatial data itself, your coordinate reference systems and your precision and that sort of stuff, and get those documented. And then lastly, you're going to take that logical structure, logical design, and you're going to now say, this is where we're going to store this thing in this folder. These are the data files we're going to create. This is the name we're going to give it, and so forth. And then actually make it happen. Put that design in that geodatabase that you've physically created, and then test and validate it, and then document what you need to prove that you did your work. Now, one thing to keep in mind is that this is not linear. It's linear from the beginning, or in that initial or beginning phase or increment. But as you get into it, you're going to bounce around from physical maybe back to logical, and then ask maybe in physical you'll be asking questions of the conceptual decisions and that sort of thing. So don't feel like this is waterfallish or sequential, and you're kind of limited to that flow of data modeling. It is free to kind of move around to hone each one of these areas of the design. We have tools to design the geodatabase as you go through these process, the process of designing a geodatabase, and we even offer up in this graphic here some technical steps that you'll go through that kind of reflect those three phases that I just mentioned in the process. So do reach out to us on these as you need help on them. Another resource which I alluded to earlier is the ArcGIS data models that we provide within our websites and if in our different solution areas at Esri. So I would absolutely encourage you to check these out. They're a great starting point. They've already been organized. The artifacts and the resources in each one of these industry data models has the conceptual documentation that we went through. It has logical design resources, and then it doesn't necessarily always go into physical, but in some cases they provide a file geodatabase that you can just use right out of the box. And each one of these things basically has a rich set of documentations, helps you kind of bring together common or typical design that we would find in a given industry, whether it's agriculture, or utilities, or public safety, and many, many others. So every major industry has a data model that you can draw on. So let's start talking about some of the recommendations now that we understood the considerations and then the design process. You're starting to get a feel for the design process. So here's some kind of recommendations that actually kind of really tie back to the factors that the common factors that we see. So for performance reasons, you don't want to ever include anything empty in your initial or operating geodatabase. It just adds overhead, processing overhead. A lot of the operations that we do in our desktop products and web apps and mobile apps will process on almost every aspect of your data. And if it's empty, whether it's empty or not, so you're wasting processing and incurring time, which could actually become a performance issue. So in the case of using like the those templates that we just talked about, you may not need all those templates, so remove them. Those that don't matter to your particular design, even though the industry might have and call for different objects to reside in the geodatabase, you may not need it for yours, so remove them. Another one is the domains that might be in there that you've either configured up initially or came with another geodatabase design like ours. They may be missing or incorrect, or the aliases might be wrong and not work for your organization. These aliases and domains and so forth are quite powerful technologies in the geodatabase, and once they're configured, they can be difficult to unconfigure or change. You'll go through a lot of work potentially on that. But the powerful thing is that these things are honored and used throughout the stack of the Esri app and ArcGIS platform spaces. So you'll want to make sure you have domains and aliases, but get them right. And then another area that we commonly see is that in the design process, the column names and the links and types of data itself may not be correct. So we want to get those right as well. Another sort of set of best practice to follow or go toward is essentially relationship classes. We recommend them, but there are some gotchas and some issues. So In the case of relationship classes, make sure you use them and don't configure them to empty tables and so forth, because we process on relationship classes quite often, oftentimes looking for relationships or related data that will help you in your visualization, like identifies, or in other processing, editing, and that sort of thing. So make sure you don't use them if you don't need them, especially on empty tables. Um, the other one is many-to-many relationships. These things are, quite powerful technologies and objects within the geodatabase that you can use, but they themselves certainly require a high amount of processing. So many-to-many relationship classes should only be used when you actually need them. And then, as I mentioned earlier, picking the right primary key or the right field for your primary key is absolutely crucial. GUIDs might be a better choice, or maybe you have your own key within your own attribute or column that you want to follow. Object IDs um, can be unexpectedly changed, the actual value, which can create some unexpected behavior in different areas like replication and so forth. So just keep that in mind is pick the right key. And then, as I mentioned, leverage these data models. If they're good for a lot of reasons. Just a good starting point, a way to kind of check your work. We've optimized these things over many years. We're listening to the industry and refining them as time goes on. So they're just a really solid resource for you to use. You want to make sure that your topology has all the feature classes it needs, including related feature classes, just so that the integrity checks and so forth associated with topology are honored as best as it possibly can, so that your data, your spatial data, is known to be good and complete and correct and high quality. The other areas is if you need more advanced geodatabase types or technologies like geometric networks or utility networks, you can use them. You're absolutely welcome to use them, and you should use them. But they are sophisticated, and you'll need some expertise. So don't go into those domains unless you're absolutely know you need them and you're ready to do it. And then another kind of class of recommendations and best practices is to where possible, use a single coordinate system. As we talked about earlier, your design will call for a coordinate system for every feature class, and so that data will be stored in that coordinate system as it's poured into the feature classes themselves. But further up the stack, as it's used in apps and so forth, if those coordinate systems don't match, you will have to reproject on the fly. So this reprojection of every feature on every operation by every user in every app can be expensive, as you might imagine. So that can be performance hits and so forth. And then there are certain technologies within the geodatabase, like the geometric network editing, that just doesn't support on-the-fly projection. So choose a single coordinate system if it's possible. And then, like I mentioned earlier, don't be afraid to create feature data sets or geodatabases for every line of business that you have, because that separation can really simplify administration and help performance and that sort of thing. So, and we can talk more about that as you need. And then quality data obviously is a certain recommendation from us and anybody. We want to make sure that the design and implementation of a quality workflow or workflows associated with just pure quality are in your mix as well. So some ideas here, and then we have tools for this, whether it's data reviewer or implementing domain subtypes topology, which are artifacts of the geodatabase. Those are tools too, and then a few others in the list here that you can check out. So. I'm Robert Kircher. If you have any questions, please contact me at rkircher@esri.com on my email, and I'd be happy to help, as well as any other geodatabase professionals within the professional services organization. Thank you very much.